Good morning, everyone. Hello, everybody. I am fine. How are you guys? Independence Day celebration has happened in full swing. Okay. Just for a small cross check, just confirm me if my voice and my video is visible to you. Others also, please confirm me quickly if my voice and video is visible to you. I don't know how is that possible. Maximum of you are able to hear me, but few people have marked not audible. To whom I'm not audible, please recheck your connection or your audio settings somehow, because I am visible to almost everybody and I'm audible to almost everyone. Seven people marked not audible. I don't understand. Please check your connection and your audio settings. All right. So today we will talk about set relation function. What kind of question do they ask from this chapter in 11th class? And what kind of things do we do here? All right. I think you have covered these three topics in your 11th class also. Well, currently you must have done it. So we will be proceeding with some further questions and some knowledge over it. I'm not going to teach too much over it. So we will be covering certain questions. See, sets may you guys are aware of everything. What is a set? It's a well-defined collection of distinct objects. All right. What is the set builder form? What is the roster form? How many subsets do a set have? And these things. All right. So now I will start with this question. Set A has m elements and set B has n elements. Total number of subsets of set A is 112 more than the total number of subsets of set B. What is the value of m cross n? Okay. So you guys take a moment, think about it, and give me the correct answer in the chat box, please. Set A has m elements, set B has n elements. Total number of subsets of set A is 112 more than the total number of subsets of set B. Find the value of m cross n. Quickly. Okay, I did not get any answer. So, if a set has, the theory point behind this question is, if a set has n elements, it will have a total of 2 to the power n subsets. All right. Now in the question they are saying set A has m elements, set B has n elements. Total number of subsets of A means 2 to the power m is 112 more than the total number of subsets of set B, minus 2 to the power n is 112. 2 to the power m minus 2 to the power n is 112. Now they are asking, first of all, they are asking for the values of m and n. Now see, from one equation, if they are asking you to find two variables, so either there is some role of maxima minima or there is a catch behind the values, like we say hit and trial values. Now see, if I take it 128 minus 16, we are going to get 112. This is very easy to judge. There's no rocket science behind it. So that means 2 to the power m is 128, implies what? M is 7. 2 to the power n is 16, implies n is what? 4. Got it? Now they are asking for m cross n. It is 7 into 4, that is 28. Very easy and simple question. Now, see, again a very beautiful question. A survey shows that 63 people in city read newspaper A, whereas 76 read newspaper B. Got it? Before that, I would like to give you a formula. If you remember, number of elements in A union B is number of elements in set A plus number of elements in set B minus number of elements in A intersection B. Got it? Now they are saying survey shows that 73% of people in city read newspaper A, 76% read newspaper B, and X% of the people read both the newspapers. Possible values of X can be. Now see, it is very much clear. If all the people who are, say, let us assume there are 100 people total. So number of people who are reading newspaper A is 63. Number of people who are reading newspaper B is 76. Number of people who are reading newspaper A intersection B, reading both of them is X. Now, if all the elements of A means everybody who is reading newspaper A is also reading newspaper B, that means this X is less than or equal to 63. X cannot be more than 63. That is the smaller of NA and NB. So if everybody who is reading A is also reading B, that means common people who are reading both will be 63. Now, if total 100 people, number of people reading newspaper A 63, number of people reading newspaper B is 76 minus A intersection B. From this, X came what? 63 plus 76 minus 100. That is 139 minus 100. That is 39. So that means X has to be more than or equals to 39. This is the range of the values of X. Now in the question they are asking possible values of X can be. So X can be somewhere between 39 to 63 including both. So the only possible answer that I have is 55. All right. This is a very good question. And a little bit of intellectual also. Have I made my point clear? Yes, 55. Got it? Now, okay, try this question. Again, very good question. Now see, set A is all natural numbers which are of 3 digits. That means starting from 101, 102, 103 up to 999. Now B is the set of all those natural numbers which are when divided by 2, when divided by 9 gives remainder 2. And C is the set of all those natural numbers which are when divided by 9 leave some remainder I. And this I is certainly lying between 0 to 9. Sum of all the elements of the set A intersection B union C is, they are saying, 274 into 400. Now tell me one thing. What will be the number of elements in set B? We will directly count the numbers which are of 3 digits, because ultimately we are taking intersection with A. So B will be having which elements? The first element that B will be having is 101. If you divide it by 9, you get remainder 2. The next number will be 110. The next number will be 119. And so on, so forth. The last number that you will be having is 992. Got it? 992. So this is an AP with common difference 9. 101, then 110, then 119, and so on up to 992. So total number of terms in the sequence will be 992 is 101 plus n minus 1 into 9. So n minus 1 into 9. This implies n minus 1 into 9 will be 891. Got it? So if you solve it, what do you get? N is 100. Got it? Now the set C. C may again I am counting the digits which are giving 3 digits number. So first number will be 99 plus I. I is not 0. I is more than 1. So definitely it is going to be a 3-digit number which when divided by 9 leaves remainder I. The next number will be 108 plus I. And so on. Last number will be 990 plus I. Or there are again going to be number n as number of numbers as 100. Got it? Now, sum of numbers in set B. And definitely B and C are not going to have any common element. So sum of numbers in set B, sum of numbers in B is what? That is 100 by 2, first plus last. That is 101 plus 992. Now, sum of numbers in set C is what? Again, 100 by 2, first plus last. That is 99 plus I plus 990 plus I. They are saying this total sum is equal to 274 into 400. So 100 by 2, this will be 101 plus 992 plus 99 plus I plus 990 plus I. It should be what? 400 into 274. Got it? This two zeros will cancel these two zeros. So you get 101 plus 992 plus 99 plus 990. This is 2182 plus 2I is going to be 274 into 8. Got it? So 274 into 8 is what? 2192. 2192. So 2I is what? 2192 minus 2182, that is 10. So I is going to be what? 5. That means set B is having all those numbers that when they are divided by 9, we get a remainder 5. Okay, somebody is asking for explaining. Once again, I'll do. See, first of all, A is the set of all 3-digit numbers. Very good. B is the set of all those numbers which when divided by 9 leaves remainder 2. C is the set of all those numbers which when divided by 9 leaves some remainder I. Alright. Sum of all the elements in the set this. A intersection B union C. You must be knowing that this A intersection B union C can also be written as A intersection B union A intersection C. Got it? So, first of all, finding the elements in A intersection B. So, A intersection B is having all those elements which are of 3 digits and which when divided by 9 leaves remainder 2. So, what will be the first number? 101, then 110, then 119, up to 992. If sum of the digits is 2, number while divided by 9 will leave remainder 2. Now, with the help of AP, I could have been able to find the number of terms that are 100. Got it? Now, A intersection C. A intersection C. A intersection C is set of all those 3-digit numbers which when divided by 9 leaves remainder I. So, first number will be 99 plus I, then 108 plus I, up to 990 plus I. Definitely it will be having also total 100 terms. Now, sum of the numbers in set A intersection B. I write it A intersection B. That will be 100 by 2 first plus last. Sum of the numbers in the set A intersection C is 100 by 2 again first plus last. If you add both of them, what they are saying, total sum of numbers is 274 into 100. Definitely A intersection B and A intersection C are not going to have any common element. Got it? So their total sum will be 400 into 274. I just simplified this equation. I get the value of I as 5. All right. I hope it has been quite clear to you all now. Now, let's come to relations. Got it? Relation is what? Cartesian. First of all, let's discuss about Cartesian product of two sets. I think you are aware of this also. Like the set A has elements 1, 2, 3. Set B has elements P, comma Q. So Cartesian product A cross B will be what? It is the ordered pair X and Y such that X belongs to A and Y belongs to B. So what will be A cross B? 1 comma P, 1 comma Q, 2P, 2Q, 3P and 3Q. This is the Cartesian product. All right. Similarly, we can find B cross A. That will be P1, P2, P3, Q1, Q2, Q3. Am I clear? Now, any relation from A to B, any relation from A to B is a subset of A cross B. Any relation from A to B is a subset of A cross B. So simply what I can say that the total number of subsets of A cross B. Total number of subsets of A cross B. See, in this particular case, A is having 3 elements, B is having 2 elements. So number of elements in A cross B is going to be 6. So total number of subsets of A cross B is 2 to the power 6. So there are a total of 2 to the power 6 relations which can be defined from set A to set B. Got it? Now, one simple question we will do first for the ordered pair. If x plus y in comma x minus 2y, this is some ordered pair and they are mentioning it as 6 comma 2. Then find the value of x minus y, 2x minus y. This is which ordered pair? So first of all, what do we do? See, these two ordered pairs, if you see with the point of coordinate geometry, these ordered pairs signifies a particular point in the Cartesian plane. All right. So if these two are equal, that means this x plus y has to be 6 and this x minus 2y has to be 2. You solve both of these equations for x and y. Solve for x and y. So to solve them, if I subtract both of them, I will get, for subtraction, you will get 3y equals to 4. So y came 4 by 3. Got it? So if 3y is equals to 4, y came 4 by 3. 3y equals to 4, so y came 4 by 3. If you put the value of y, you get x as 6 minus y. That is 6 minus 4 upon 3. 18 minus 4. So 18 minus 4 is what? 14 upon 3. So your ordered pair xy came as 14 upon 3 comma 4 by 3. Got it? Now they are asking for x minus y. X minus y will be what? 14 by 3 minus 4 by 3, that is 10 by 3. They are asking for 2x minus y, that is 28 by 3 minus 4 by 3, that is 24 by 3. 24 by 3 is 8. So your x minus y comma 2x minus y came as what? 10 by 3 comma 8. So this is how we handle such simple questions. Got it? Now, what I'm going to explain you now basically is in class 12th syllabus from relations, but generally in everywhere in the JEE coaching, we do it in 11th class only, which is it's very simple thing also. All right, so we will do it now. You will also see their questions in your AIET. So that is why I'm covering it right now. And that is very important. Every year in JEE mains, we can expect one question from that. So classification of relations. Classification of relations. Before understanding classification, I'll say explain one line. If in any question if they say that a relation is defined on set A. If a relation is defined on set A, that means that relation is a subset of A cross A. Got it? Generally, what you have studied in class 11, if a relation is defined from A to B, what do we say? It is a subset of A cross B. Now, sometimes if they say that a relation is defined on set A, that means what? It is a subset of A cross A. Got it? Now, relations are of three types. It is of reflexive relation, symmetric relation, reflexive relation, symmetric relation, and transitive relation. Reflexive relation, symmetric relation, and transitive relation. And a relation, and if a relation is all three of them, then what we call it equivalence relation. Equivalence relation. If a relation is a reflexive relation, symmetric relation, and transitive relation, it is an equivalence relation. All right. Now, say there is a set A, 1, 2, 3, 4. Definitely this A cross A will be having a total of 16 elements. 1, 1, 2, 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, 2, 4, 3, 1, 3, 2, 3, 3, 3, 4, and 4, 1, 4, 2, 4, 3, and 4, 4. So if a relation is defined on set A, means it is a subset of A cross A, which is having 16 elements. Now, what is a reflexive relation? See, if every element of set A is related to itself, if every element of set A is related to itself, that means what? Say A is having elements 1, 2, 3, 4. So every element of A is related to itself means 1, 1, 2, 2, 3, 3, and 4, 4. If all these four elements are there in the relation, we call that relation reflexive relation. If any one of them is missing, the relation is not reflexive. Got it? So if 1, 1, 2, 2, 3, 3, 4, 4 are present there in the relation, it will be reflexive. Got it? So if every element of set A is related to itself, a relation is reflexive. Got it? Like according to this set A, 1, 1, 2, 2, 3, 3, and 4, 4 should be present in the relation. 1, 1, 2, 2, 3, 3, and 4, 4 should be present in the relation for the relation to be reflexive. Got it? Now, what is a symmetric relation? Symmetric relation. Now see, if AB belongs to relation and BA also belong to relation, it is symmetric. Got it? If AB is there in the relation as well as BA is there in the relation, we call this relation symmetric. Like if I write a relation R, that is 1, 1, 2, 2, 1, 2, 2, 1, 1, 3. I have written this relation over the given set A. Now tell me one thing, is this relation reflexive? First of all, let's talk about reflexive. Is this relation reflexive? Quickly reply. Is this relation reflexive? No. Very good. Whoever answered no, because there are not elements 3, 3 and 4, 4. Got it? So it is not reflexive. Now come to the point. Is this relation symmetric? Again, no. Why? See, 1, 2 is there, 2, 1 is also there. It's okay. But 1, 3 is there and 3, 1 is not there. Got it? With respect to 1, 3, 3, 1 is not in relation. So, not symmetric. And any relation, either it is symmetric or it is not symmetric. Got it? It does not happen that it is 50% symmetric, it is 60% symmetric. It's not like this. If there is even a single problem which is signifying not symmetric, it is not symmetric. Got it? Now let's come to transitive relations. Transitive relation. If AB belongs to R and BC, AB belongs to R and BC also belong to R, then if AC also belong to R, we say it is transitive relation. Got it? Like there is a relation R, if I write 1, 1, 2, 2, 1, 3, 3, 2, 1, 2. Now see, because of the presence of only 1, 1, 2, 2, it is not not reflexive. Now 1, 3 is there, but 3, 1 is not there. So it is not symmetric. Now, if I go for transitive, 1, 3 is there, 3, 2 is there, and 1, 2 is also there. So it will be transitive. Got it? So reflexive is not, symmetric is not, but it is transitive. Got it? Now let us see a simple question over it. A is a set of all triangles in a plane. In a plane, as many number of triangles can be there. A is that. All right. A relation R defined on A is such that A comma B, AB belongs to A and A is congruent to B. That means this relation is the collection of those ordered pairs where both the elements, first and second, where both the elements are two triangles which are congruent to each other. Now, tell me, is this relation reflexive? Is this relation reflexive? Yes, because every triangle is considered congruent to itself. Every triangle is considered congruent to itself. So this is reflexive. Now, is this relation symmetric? Yes, because if A is congruent to B, then definitely B is also going to be congruent to A. If triangle A is congruent to triangle B, that means B is also congruent to triangle A, so it is also symmetric. Now, is this relation transitive? A is congruent to triangle B, B is congruent to triangle C. Is A is congruent to triangle C? Yes. So, since this relation is reflexive, symmetric, and transitive all, it is an equivalence relation. The relation is reflexive, symmetric, and transitive all. It is an equivalence relation. Am I clear? Now we'll start a bit about functions. See, have you all studied functions in your classes? Please tell me. A few of you, please mention if you have studied functions. Very good. Okay. So we will do few questions over the domain and range of a function. Domain and range of a function. Say you have a function fx is under root of 2 minus x. Now, how do we find the domain of such functions? Whatever is there inside the under root. Whatever is there inside the under root, it should be greater than or equal to 0. Whatever is there inside the under root, it should be greater than or equals to 0. Second thing, whatever is there in the denominator, it should not be 0. Like if I ask you the domain of the function under root of 2 minus x, got it? How to find the domain? That is 2 minus x should be greater than or equal to 0. Implies x minus 2 should be less than equal to 0. So x should be less than or equals to 2. So domain is what? X belongs to minus infinite to 2. This is the domain of the function x belongs to minus infinite to 2. Got it? Now, if I give you another function, 1 upon x square minus 6x plus 5. See, what can I write it? 1 upon x minus 5, x minus 1. So domain of this function will be what? Everything except those points where denominator is getting 0. So x minus 5 into x minus 1, it should not be 0. So x should not be equal to 1 comma 5. So domain is what? X belongs to r minus 1 comma 5. Domain is x belongs to r minus 1 comma 5. Am I clear? Domain is x belongs to r minus 1 comma 5. Now see the next question. Fx is 1 upon under root of x minus 5. Now see, this x minus 5 is inside the under root as well as it is in the denominator. It is in the denominator. So because of under root, it has to be greater than equal to 0. Because of the under root, it should not be 0. So domain, how to find x minus 5 more than 0. Here equality won't occur. So x minus 5 more than 0 means x is greater than 5. So domain is what? X belongs to excluding 5. X belongs to excluding 5 to infinite. Got it? Now see another question. Fx is under root of x minus 2 plus under root of 6 minus x. Under root of x minus 2 plus under root of 6 minus x. Now, see, this x minus 2 should be more than equal to 0, means x should be greater than equals to 2. Simultaneously, this 6 minus x should be greater than equal to 0, means x should be less than or equals to 6. Now, domain will be what? Domain will be intersection of this and this. Now, how do we take intersection? Make a number line, mark both the zeros 2 and 6. One is saying x is from 2 to infinite. Other is saying x is minus infinite to 6. This is their common portion. Got it? So your answer is x belongs to 2 to 6. Very simple question and as well as very good question. Now I'm going to cover a very amazing question. Fx is 1 upon under root of x minus 2 minus under root of 4 minus 6. Got it? X belongs to under root of x minus 2 minus under root of 4 minus x. Now, how do we do them? See, one by one we will see. This x minus 2 should be greater than equal to 0, means x more than equals to 2. First case, this 4 minus x should be greater than equal to 0, means x is less than or equals to 4. Second thing, simultaneously, what do you want? This denominator should not be 0. So denominator should not be 0 means under root of x minus 2 should not be equals to under root of 4 minus x. Yes or no? Now if you square both sides, you get x minus 2 should not be 4 minus x. So 2x should not be 6, means x should not be 3. X should not be 3. Now domain will be what? Domain will be intersection of all three of them. So your domain will be x belongs to 2 to 4, excluding a single value 3. Got it? X belongs to 2 to 4, excluding a single value 3. Now let's talk about a bit of range. See, there are different ways to find the range of a function. N number of questions might have n number of ways to find the range. So simply if I should say there is no range to find the range of the function, n number of ways. So few we will talk about. Let you have a quadratic polynomial. Quadratic polynomial, that is fx equals to x square ax square plus bx plus c. This is a quadratic polynomial. Now we all know these quadratic polynomials have parabolic graphs. Now the graph of any quadratic polynomial is either like this or it is like this. Now, how do we decide the graph is which one? That depends on the value of a. That depends on the value of a. So if a is positive, it will be an upward opening parabola. If a is negative, it will be a downward opening parabola. Got it? A positive, it is an upward opening parabola. A negative, it is a downward opening parabola. In any case, this bottom point or this top point has coordinates minus b by 2a minus d by 4a. And if I use the method of completing the square, we get this bottom and top point. Here also the stop point will be minus b by 2a minus d upon 4a. Am I clear? Now range is what? Range is the values of y on the graph of the function. If you realize the minimum value of y on this graph is minus d by 4a and maximum value of y is going up to infinite. So if it is an upward opening parabola, range will be minus d by 4a to infinite. I hope you know d is b square minus 4ac. Where d came from? Okay, I'll explain it also. And if it is a downward opening parabola, this range will be minus infinite to minus d by 4a. All right. Now see where this d came from. The polynomial function you are having is ax square plus bx plus c. Take a common, you will get x square plus b by ax plus c. To complete the square, how do we do? I will write the strategy completing the square. Completing the square. How do we do it? After making coefficient of x square as 1, which I did, took a common and coefficient of x square came 1. After making the coefficient of x square as 1, add and subtract the square of half of coefficient of x. Got it? Now, after making the coefficient of x square as 1 or minus 1, coefficient of x is b upon a. Half of that is b upon 2a. Square of that is b square upon 4a square. Add and subtract. The equation is balanced. There is no difference. Now, these three collectively, what do? They make a times x plus b by 2a whole square plus c minus b square upon 4. So it is a times x plus b by 2a whole square plus, in the numerator it will be minus of b square minus 4ac upon 4a. Yes or no? And this b square minus 4ac is what? D. So it is a times x plus b by 2a whole square minus d by 4a. Got it? X plus b upon 2a whole square minus of d by 4a. Now this fx. See, this perfect square is having, if a is positive, this perfect square will be having minimum value as 0. Yes or no? Minimum value of this perfect square will be 0. So minimum value of overall function will be what? Minus d by 4a. Fx minimum will be minus d by 4a. And if a is less than 0, if a is negative, maximum value of this perfect square will be 0. Otherwise, it will always be negative. So in that case, maximum value of the function will be minus d by 4a. Fx maximum will be minus d by 4a. All right. I hope I have made my point a bit more clear to you guys now. So minimum value is minus d by 4a. Maximum value is minus d by 4a depending upon the value of a. Got it? Now, and that is why I have written range as minus d by 4a to infinite if a is positive and minus infinite to minus d by 4a if a is negative. This is in closed bracket here. Got it? Now a simple question if I do, say fx is 3x square plus 4x minus 5. Domain of this function always R. It's a polynomial function, domain is R. If you find its D will be b square minus 4ac. So that is 16 minus 4 into 3 into minus 5. So that will be 16 plus 60. That is 76. Got it? So range will be what? Minus d by 4a to infinite. That is minus of d is 76 upon 4a. 4a will be 12 to infinite. That is with a negative sign. No, that's it. Minus 76 upon 12 to infinite. Got it? One more thing. A range of all odd degree polynomials. Odd degree polynomial means linear polynomial, cubic polynomial, fifth degree polynomial will always be y belongs to R. Got it? Okay. If you have a question like y equals to x square upon 1 plus x square. X square upon 1 plus x square. Now they are asking you to find the domain and range. See, domain is simple, x belongs to R. There is no under root. Denominator is never getting 0. So domain came x belongs to R. Now, how do we find its range? What do we do? Write x in terms of y. So y plus yx square is x square. So your x square came y upon 1 minus y. Now we all are aware that x square is always greater than or equal to 0. So y upon y minus 1 always greater than equal to 0. Sorry, y upon 1 minus y. 1 minus y. So y upon y minus 1 less than equal to 0. And if you just analyze, you will realize that this y lies between 0 to 1. Got it? So this is how we find their range. So I hope I have been able to add some values to your concepts. Got it? So let us now end this class. I will leave you guys with a feedback form.